Hello, 7th grade. Last week we went over the test, the assessment A, and to pretty good effect. We had pretty good improvement in our test scores from A to B, so I'm pretty excited about that. However, it's time consuming, and I hope that, well, anyway, I'm going to make this video where I explain the test as quickly and as concisely and as effectively as I can. I hope that you enjoy the fact that I'm trying to make this as brief as possible, but you know, these assessments, they encompass a lot of different things. So without any further ado, let's go ahead and jump on in. The first problem, pretty straightforward, is a graphing problem, and we'll go over the differences in graphing inequalities in class today. But if you chose A, you're absolutely correct because of the sign. Since x is greater than, we're talking about all the numbers x can be that are bigger than 26. But they don't include 26. If it had a line under to it, we would have said x is greater than or equal to 26, in which case we would have colored it in like letter C would be. So the answers for the first one was obviously A. So if you got that one right, hooray, good for you. A lot of you did. Alright, so the second one, let's see, here's the second one. The second one was kind of cool. Well, I thought it was kind of cool. Once again, we got one of those fractions, and a lot of us still are worried about a fraction. I did it over here as an equation to begin with, but the main takeaway from this problem, let's see if I make it a little bit bigger, is this. Whenever you have a fraction, get rid of it. Use your magical pencil to destroy the denominator. All right. If you see a denominator of 6 and you multiply the fraction by the denominator, it'll make this fraction disappear, so the 6's are going to cancel out. Now I have negative 6 times 1. I brought the 6 down here. I have the negative y left over. Of course, and at our level, we're not very concerned about what negative y equals, but we do want to know what y equals. So in order to get that y positive, we just multiply it by a negative 1. You could also divide it by a negative 1. It has exactly the same effect. So in this case, I have negative 6 is less than y. And this, if you noticed, the sign has flipped. The sign is flipped. So I hope that, and we'll talk about this. This is the trap that I talk about in class. Yeah, so hopefully that'll make more sense to you today if you haven't figured that out already. All right, so there's number 2. Where's number 3? Number 3, is that you? Number 3 was, I think, our first word problem. I know you guys love word. A lot of you guys are really good with word problems. It's pretty impressive. Okay, so every month Tracy writes a check for $25 to pay off a loan. She has enough in her checking account to pay no more than $450 towards the loan. For how many months can Tracy send payments for the loan? All right, good strategy for this one is, excuse me, a good strategy for this one for me is to, we know we're dealing with an inequality, and so that means there's going to be a variable somewhere. So the first thing I want to do is figure what is it that we're looking for? What is the question actually answer us? And hopefully that will be reflected in our variable. And down here I have it highlighted. For how many months can Tracy send payments for the loan? How many months? So I said let M equal the months. All right, so my first line here, and I'm going to use this little tool right here to kind of block off, you know, a terrible block. Let's see if I can move it up. So the first move, right, was just to write the equation in which, you know, Tracy is spending $25 a month, hence the term, or hence this coefficient 25 times n is less than $450 period. And now the reason why we use this inequality is because of the language they use. It says no more, all right, so it's no more. So it's greater or less than, or right, so we'll see how that works out itself out. As we go down, we isolate just like we do with equations. Let's see, by getting 25 and dividing it into 450, which I believe drops us at 18, which is kind of confusing because if they're going to say, you know, her checking account no more, then you would assume that there would be more money in the account. There might be a remainder or some kind of weird decimal, or you know, but who knows? It is what it is. So there's your solution for that one. M is less than 18 months. It should be less than or equal to, I think. I don't know. It doesn't really say that in the equation, and that's why, or the inequality. So that's why I left the sign there. Right? The language and the word problem didn't talk about it being equal to. So that's the solution I accept for that. If you have a better solution, or if you think this is wrong, or if you have an idea, leave me a comment, send me a private chat during class, an email, whatever you'd like to do. If you want to disagree, please do. I welcome a little discourse. All right, so let's see. Number 4 is right here. Number 4. Okay, so number 4 was just a straight up question. They want to know if you know, or if I taught you. Let's see. Move this over here. When solving an inequality, when do you reverse the inequality symbol? And we'll talk about this, like I say, in class, but I'll just say it right now. Whenever you multiply or divide by a negative number. This is the trap, and after today, you're going to be so sick and tired of me saying this. Yeah, it's going to be, I think it's going to be awesome. So, we're multiplying or dividing by a negative number, and you can see my smiley face right here, because that's exactly when you flip the sign. Okay, and then, last but not least, we have the ultimate, the number 5 question, the bad boy. And I kind of like this one for a couple of reasons. Alright, so here we were with Craig. I don't know if you guys remember Craig from our benchmark question. He gets around with his bowling. So he went bowling again and spent $25. But each game he bowls cost $5.25. Right, solve an inequality to determine the maximum number of games Craig can bowl. So once again, my strategy or my thinking on this is let's go and find ourselves a variable. Well, what's the question asking for? Well, it seems to me like the maximum number that Craig can bowl, and over here I've got the first line. We can use this box again, hopefully. Bear with me. I know it's not pretty. Let's see here. Make it just a little bit longer. All right, and then we'll just boom. It's like it wasn't even there. I'm even going to change the color of it, just because I don't know. That color's so boring. Let's go with how you like that. All right, so I have 25 is greater than whatever 525 times y is. Because remember, and I wrote this in order like this on purpose because these are the way the numbers show up in the word problem. You could easily just flip this around. You would just have to change the sign to reflect the same thing. And we can talk about that more in class. But let's go ahead and get through this. Once again, like I say, we have class time today. I'm going to show this to you guys at the beginning of the class. I'm going to post it in our Google Classroom. And if you think that I'm wrong, or if you think that I've got my signs wrong, or whatever, I would love to hear from you, because that means you're thinking, and that's really all I can ask for. So 25 is greater than $5.25 times y. That's the cost, or excuse me, g. G equals the number of games. That was my variable. So the first thing I did is I divided both sides by 525, and I get this ridiculous number down here. And I just rounded it up, but I got my calculator out here because it's kind of a fun number to look at. When I look at 25 and 525, I think that these are going to break into a pretty even, but it's not true. Look at this monster. You don't see a repeating decimal like this every day. Or, yeah, so it just goes on. Let's see, it repeats 1, 2, 3, 4, 5, 6 places before it starts repeating again. I don't know, it's just kind of interesting. You don't, like I say, see too many of these, but it is a pattern. You can definitely look. This is a great example of a rational number that kids might confuse with an irrational number. But just remember, if you can tell me by looking at the pattern with certainty that you know what the next number is going to be, then you found yourself a rational number. All right, guys, I hope this has been helpful. I hope you use this in your notes. I hope you write this stuff down and put it in your own personal little cheat sheet. Yeah, there you have it. Like I said, text me or private chat me in class, send me an email. raise your hand, whatever it takes to get my attention if you have any questions about what I've talked about today. All right, we'll see you in class. If I can find the stop record button. Maybe. Oh, come on. Look at that.